Welcome, everyone. This is Jim Sporer with ISSIP, the International Society of Service Innovation Professionals. I'm delighted today to introduce congratulate one of the Distinguished Recognition Award winners for our Service Excellence Award, Roberto Zicari. And let me just briefly share the certificate here, the ISSIP certificate. And I'm going to ask Roberto if he'll introduce himself a little bit more fully, tell us about Z Inspection. I really enjoyed first hearing about Z Inspection several years ago, pre-pandemic. We were just talking, Roberto, that you joined us at the Almaden Research Center and gave a fantastic talk back then. I'm sure there's been a huge amount of progress, and I'll stop share, let you share, and we'll be on our way. Thank you again.
Thank you, Jim. First of all, thank you for the very kind invitation. And obviously, thank you for the distinguished award, which is really very much appreciated. And as Jim was saying, I visited Almaden pre-pandemic, explaining some of this work. And now I'm quite happy to present in a nutshell the, what we'll be doing in this period. My name is Roberto Zicari. I'm leading an initiative called Z Inspection, which is a non-commercial initiative under Common Creative. And the title is basically giving you the rationale of this initiative. We wanted to really understand how to assess AI system for trustworthiness in practice. So for those of you who are attending this session, if you are planning to use artificial intelligence, or you're developing yourself, or you're a stakeholder that need to make a decision whether a particular AI product or service is suitable for whatever context you have, or if you are like an auditor that need to validate some of the products that are already there, maybe this work that we've been doing might be of interest for you. So I think it's important that I place the context of our work in what we do here. Basically, we've been following what the European Commission have worked on, the definition of what they call trustworthiness of AI system. And this is actually rooted in one view of the world. So I think it's important for us to see that is view of contemporary Western European democracy, because most of the work of the European Commission is actually based on fundamental human rights. So that's actually an important point, because there are plenty of definition of ethical values and even guidelines for trustworthiness. And we've been choosing the one of the European Commission. The European Commission actually set up back in 2018 a so-called high-level expert group that were supposed to define ethics guidelines for trustworthy AI. Now, I put guidelines here because this is not a law. They've been published in April 2019. Now, the interesting thing, these are guidelines, but the European Commission is also working on a proposed law, the so-called AI Act. There's a draft version taking into account quite a bit of these guidelines. So that's why the guidelines are connected to maybe a future regulation, at least in Europe. This regulation might happen soon, maybe less than 2 years' time. We'll have a AI regulation risk-based, kind of similar to what they do here on data, like the GDPR. Anyway, this is a guideline for the moment. We've been using this. And the guidelines are defining trustworthy AI as 3 pillars. It should be lawful, respecting all ethical laws and regulation. Now, the interesting thing, there is not a specific law and regulation for AI, but there are plenty of law and regulation for specific domains. So waiting for the specific law on AI this is basically if you're in financial sector or in healthcare or any other domain, there are plenty of laws and regulations that you should respect. So the second, it should be ethical, respecting ethical principles and values. Now you might ask yourself, who is defining the ethical principle and what are the values? You see they have a proposal. And the third pillar, it should be robust. Now, the interesting thing, under robust, they not only have the usual technical perspective, which you will be expecting, but they also take into account a broader social context, the social environment. Now, this is just the pillars. And the way they structure the framework, they define ethical principles, again, rooted in fundamental rights. That's why I had the first slide mentioning that. The first three, respect for human autonomy, prevention of harm, and fairness, you'll find it in biometrics. But the fourth one, they invented a new one called explicability. They even created a new word because it's not called explicability, it's called explicability. And although these are very general principles that you might need to give a particular semantic, these four ethical principles are not enough for assessing any AI system. They're just guidelines, ethical guidelines that could be useful in the ways of discussion. And on top of that, it's well known that when you have ethical principle like this one here, you might have tension between principle. So you might have a value that is in contradiction to the other one. So there is a so-called tension. Now, they realize that for practitioners like us, this is not enough. And so they went through a next step and they defined 7 requirements. When you see the word requirements, it already sounds more engineering. And there was this attempt to go from very abstract ethical principle to some actionable requirements. The 7 requirements are being published again in 2019 and are this one here, human agency and oversight, which also includes a fundamental human rights assessment, technical robustness and safety, so that's more the technical space, privacy and data governance, and here in Europe we have GDPR as obviously a linking law. And here you can see transparency. Now, transparency is a requirement that is derived from this new ethical principle, explicability, and includes all possible ways of trying to either explain or communicate the results of an AI system. If the AI system is a black box, and so it's not transparent, nevertheless, this requirement forces you to look at how you explain, at least, or you communicate to whoever is involved, the output in AI. And then you have here diversity, non-discrimination, fairness. And here you have something extremely general called societal environmental well-being. If you go deeper, because here for each of these requirements, you have sub-requirements. I didn't write it here for not confusing too much, but here you have deep topics that are kind of embedded. One is democracy, if the AI is endangering the key value of democracy, and the other one is societal. So, and this also has to do with sustainability, and environmental. So this is a huge area. And the final one is called accountability. Now, these requirements are not legally binding, so this is not a legal assessment, supposed to be, but accountability is a link to responsibility. So if something goes wrong or there are risks, who's responsible, there's a need of redress or anything that might actually be linked to that. And the idea that they have is that all of these 7 requirements should be continuously evaluated and addressed through the AI system lifecycle. That's on paper. They even have a static checklist with the tool where you can enter, there's a web tool with questions for each of these requirements. You can do your self-assessment by answering questions, and the tool is basically computing a score and giving you some recommendation. So that's basically what the European Commission has come up with, and publish it and try to promote it in Europe, at least, or throughout Europe. Now, when we started the work and I met Jim and his colleague in Almaden a few years ago. The question is, okay, these are very nice guidelines and a nice checklist, but if I have a real case, how do I assess it in practice? What does it mean if somebody is coming to you, maybe in your department, in your hospital, and say, I have a great tool that is supposed to improve the work of your radiologist, or improving the work of cardiology to detect certain kind of diseases, just to mention something. How do you make a decision? How do you basically assess if this tool is actually beneficial for whatever business you have, or might have unintended consequences and potential risk? So that's basically all the things we were looking at, considering that the EU framework for trustworthy AI, and there are many more frameworks for trustworthy AI. The UN came up with, the OECD came up with some. So there's plenty of those. They all come from ethical principle, and they kind of try to define areas where you should be doing something in order to be good. But at least, in case of the EU framework, they stop like a static checklist. Static means that you do it once and then nobody's going to verify the answer. So it's just for you. And they do not validate your answer. So if there is a claim, like, my system is very accurate and is much better than, for example, the work of a dermatologist, there's no claim that you are validated. You just simply give an answer. So, and also it doesn't take into account an important aspect that an AI is changing over time. At least some of the AI is learning. And, it's like, then you need to reevaluate this every time. On top of that, these are general guidelines. They're not specific for one particular domain. And the AI system is not the same in healthcare, in financial sector, in transportation, in communication, news, or whatever, in supply chain. So that means that some of the concepts that they have, like fairness, for example, how do we define fairness? Fairness is totally dependent on the context and the use case. So well-being is another definition. So somehow it's a good start, but to make it practical, we had to do some work, and we're practitioners, so we've been working on real cases. And by working real cases, we come up with I would call it participatory process or orchestration process, where we are able to coordinate a number of high-level experts or stakeholders looking at the implication of using an AI system in particular context on 4 areas. You're looking at the ethical part, so there would be some of the requirements that we've seen, the technical space, the domain specific, because it's really dependent on the domain, and the legal implication. Although we are not doing any legally binding assessment, but I think it's quite important to understand the legal context where the AI system is either developed or deployed or used. This work is under common created attribute, non-commercial, so it can be used for non-commercial use, and the name is protected just to avoid that it's being used improperly by somebody that then use it for other reasons. Now, as I said, there are 4 areas that one can look at trustworthiness. So the AI life cycle has the design phase, where normally in typical engineering situation, you have engineers, working on designing an AI system with an idea of the benefit. Then there is a development, depending on whatever kind of development. And then here you basically are mainly working with engineers and maybe some domain experts. Here, there's a moment where somebody has to decide on the deployment. Now, this could be a product, so then the vendor might deploy, but it could also be that the system is being developed And the deployment is in the case. So, for example, in a hospital, or shall we deploy this system in our radiology department? And then finally, but not less important, is monitoring, because all of that changes over time. Now, trustworthiness can be applied in design phase and development as much as in assessing post-deployment and monitoring over time. So this we call it pre-ante assessment. This is post-ante assessment, the legal people say, and monitoring. Now, you might ask, but what did you learn? Well, we learned quite a bit, because basically we did assessment of real cases, so not academic cases. When Jim kindly invited me to present our first assessment, we were actually in this space. So it was actually, as I said, before pandemic. And we just finished doing two important things. One is to assess a real AI system for predicting cardiovascular risk. But that was instrumental for us to learn how to create a process. After that, and this is the new thing, in the next years, we've been using this process and validated in real cases. In this case, which lasted from September 2020 to March 2021, so very long assessment, we worked with the city of Copenhagen in Denmark, and in particular with the emergency call services. So when in Europe, if you call 112, which is in the States 911, is a health-related emergency call. You call, and on the other side of the line, there is a so-called medical dispatcher, or is a paramedic that answers the phone and try to understand why you're calling, what is the urgency, try to understand what is the situation, and most likely send an ambulance and basically try to solve it. Now, the city of Copenhagen discovered, well, actually the emergency service, which is a number of hospitals, discovered that of all the calls that have to do with so-called cardiac arrest means that the heart stops beating, so the person is unconscious, to be dead. Of course, he cannot call, so there should be a bystander somewhere in the house calling, likely in panic, and try to explain on the phone that somebody unconscious, please call, please come. On the other line, the so-called dispatcher would have to understand why this person is unconscious, and he has a protocol of question that he needs to answer, and try to understand if the person is unconscious for a cardiac arrest. Then you have 5 minutes in order on the phone to give instruction for a cardiopulmonary resuscitation. So you press your hands on the chest and you try to reanimate the person. If you don't do it within 5 minutes, the brain could be damaged. And even if you send an ambulance and you arrive in late, the person might be either dead or compromised. And 25% of all these calls were not detected as a kind of analysis they done. So what they did, they have worked with the startup from a university in Copenhagen to deploy, using their data, their audio files on their call, a machine learning system that is listening to the call, looking at the pattern of communication, and alerting, like an Alexa box, predicting if there is a possible cardiac arrest. Now, I'm taking a bit of time because that's an interesting case, because although they did some clinical trial and retrospective work, where in laboratory, this system was very accurate. So in retrospective study, analyzing 1 year, this called the AI system was very accurate. When the system was tested in a controlled trial with 2 groups of people, dispatcher on their own, answering the phone, and dispatcher with the machine, answering the phone, the dispatcher did not pay attention to the AI. So that's the interesting situation. So in real situation, although it was a control situation, the human being involved in making decisions did not pay attention to the machine. Nevertheless, and that's a very interesting observation, somebody in the emergency services who had the responsibility decided to deploy. So that was deployed actually in 2019, although they had this mixed information. On one hand, the system's supposed to be very accurate and saving lives. At the same time, when they did the controlled trial, it didn't really work very well. So we did a self-assessment with them. They asked us to do a self-assessment, and we completed the self-assessment a few months later, and there's a publication that you can read. And we find out interesting things like that possibly this system is biased if you don't speak proper Danish. So if you speak another language, or you have a dialect, or you are not mother tongue Danish, the system was only trained with mainly Danish people, but you couldn't really look at the system because it was a black box. So we gave a few recommendations. You see, that's part of the presentation. Anyway, so this is big assessment post-ante. So it was assessed after the system was already deployed. We have also experience in doing co-design with engineers. We've been working with engineers of the German Center for Artificial Intelligence in Germany. They were developing some deep learning for detecting skin lesion, helping dermatologists, and we brought a team and we did a co-design with them, and we turned their design into an initial trustworthy reassessment of the design. And finally, we finished last year a very long assessment with a hospital in northern Italy, in a city called Brescia, which is actually one of the cities that during pandemic was hit, unfortunately, heavily. And in that particular time, the hospital, which is the public hospital part of the university system, together engineers and radiologists decided to implement a deep learning system for helping radiologists to predict the so-called degree of lung compromise of COVID patient. Now they asked us afterwards to help with the assessment. And the interesting difference between this case and this one here, that here there have been clinical trial, retrospective study before somebody decided to deploy. Here, under pandemic, since there was a lot of tension and time pressure, they deployed the system without any clinical trial. So the interesting question that we're addressing here is not only how trustworthy is the AI system, how trustworthy is their use, but what does it mean trustworthiness in times of pandemic or emergency, like in this particular case? And also we finish all this assessment. This has been published, and this will be soon be published. So this is just to give an idea. We've been working mainly on healthcare, although our assessment can likely be used for other domains. And we don't only use checklists, but and static check. We do a holistic approach by bringing together many stakeholders, or the most important one related to the case. Now, basically, this means creating an interdisciplinary team of experts that, together with the owner of the case, look at the implication. You might wonder what kind of expert they are. You go from applied ethicists to domain experts, to social experts, to machine learning engineers, to representative end user, and so forth. So, and the way we work, we bring together this interdisciplinary team. Suppose that the system is already being deployed, and we try to understand what the implication. By doing that, we use a technique that is well known called Socio-technical Scenario. And basically, we gather together experts and the owners of the case, and we create scenario where we try to understand the aim of the system, who are the actors, and the actor might be primary actor, secondary actor, third actor, their expectation, their interaction, and maybe the contradiction between the expectation, because each one brings his own view, the process where the AI system is used, especially if a decision to be made, the technology and the context, and in particular, the boundaries. So what you want to assess is not only the software, you want to assess the ecosystem. And to define the boundary is very important, especially if the AI system is part of a supply chain where it's embedded and the output might have an implication only later in the chain. So one has to upfront decide what are we assessing. And then basically by doing iterative workshops, in those days we do online workshops like this and we share documents, we look at that and look at issues that could come up of using this AI system. Now, when you have an issue like, you're not sure whether this particular feature or this particular claim is true, you have to develop an evidence base. As a claim, the system is very accurate and is actually able to detect with, 95% probability a particular disease. That's a claim. And then you need to figure it out. How do I get a supporting evidence? Well, this is actually a very important part of the process, which is iterative. And you need people with different skills and background, because not only you have to understand the technology, but also you have to understand what has been already proven in the specific domain. So if you're in healthcare, maybe there's been studied, that have been published already mentioning that certain kind of feature will be important to determine, for example, a cardiac arrest. And this has been proven in studies. So if your system is somehow related to that, you could have a kind of strong evidence. Of course, the strongest evidence would be in healthcare having clinical trial, but not all systems that are actually in production went through clinical trial, because there is not really a law that forces all kinds of AI systems to be medical device. So that's basically one of the things is developing an evidence base. Once we have develop an evidence base, then you might have these experts that are still thinking there are issues. And each expert that comes from a different background, could be a legal scholar, could be machine learning engineers, it could be, for example, a medical doctors, or it could be a specialist in medical doctor, or it could be an evidence-based medical doctor, or a social worker, or whatever. They describe the issue with their own vocabulary, with their own terminology. And that means that you have a lot of overlapping, because people with different backgrounds, they will likely describe things in slightly different way. So how do you reach a consensus? That's actually one of the original part of our process, because we reach consensus by basically letting the experts talking to each other with their own terminology, describing the issue with their own narrative, but then forcing them to reach consensus how to map this narrative, which is open vocabulary, into templates, that we call it closed vocabulary, mapping to some of the 4 ethical principles that I mentioned before, and some of the 7 requirements of trustworthy AI. So basically you have a descriptive issues, and the team, we call the team mappers, because then the people with different background, they will need to agree, how do you map it to one particular ethical principle, would be explicability, and how you map it to the requirements. There could be transparency and accountability, for example. And by doing that, you're forcing them to reach a consensus, and then you rank these map issues by relevance in the context of the use case. Now, by doing that, our aim is to basically to provide to the key stakeholders a list of recommendations based on this issue that did not have enough evidence. Of course, an issue is no more an issue if there is evidence, but an issue that does not have a strong evidence becomes a possible risk or an implication. So when you have this list and you map it to meaning that you can explain, because then you say, well, there is an issue, it could be that there's a fairness, ethical principle, and accountability requirement for this particular element of the use of this system, then you can give recommendation to the key stakeholder that can be held to make a decision. And the recommendations are not legally binding, and we do not certify, we're not auditors. But it could be, well, it's appropriate to use it, or we found risk. And if we were able to find ways to mitigate those, give them, bear with me that you could also present trade-off, because there might be some ethical dilemma or tension that cannot be solved, and you can present trade-off transparently. Or the system has so severe issues that either shouldn't be deployed at all, or if it's already deployed, it should be redressed if it's possible to reduce any kind of risk. Now, you can still, do all of that without our assessment, but then how you justify your decision is different. At least here we give some qualified information that obviously is subject to who's the team, how long was the assessment, how the consensus was based. So there's some obviously limitation is subjective, but at least we are able to provide qualified information with sustainable material for stakeholders to do a decision. Now, the assessment in a nutshell has the following phases. There's a setup phase, there's an assess phase, and there's a result phase, and we have a protocol. Now, in the setup phase, at the very beginning, we ask questions such as, why do we want to do an assessment? Who has asked for the assessment? What do you want to do with the assessment? Can you publish the results of the assessment? And most importantly, we verify if there's any conflict of interest. In my experience, this is basically very critical when you work with a vendor or with a company who has a deep business interest and he still wants to do a self-assessment, because there might be inherent conflict of interest between different stakeholders. If that's the case, we don't do the assessment. Once we understood that there is no conflict of interest and everything can be transparently published, even the list of risks, then the interesting and important decision is how to create a team. The creation of the team sounds like trivial, but how many people, what kind of people, how many people from the owner of the case, and how many people are neutral. And so we have several experiences with that, with small teams, with huge teams, but the formation of a team has an ethical implication, because if the team is biased for some reason, then obviously all the work would be biased. If a team is too small, is not interdisciplinary enough, then you don't have the broad vision. If a team is too big, then you start breaking the team in working groups, the interdisciplinary aspect get diluted, and then you have to re-merge it in a very complex way. So we have some best practices that we learn from various cases. And it's important that you have skilled people with their own field of expertise covering at least the 4 areas that I was talking about. And then important is to decide upfront what is the boundary of what you want to assess. It seems like trivial, but it's not, because it might end up being also a very non-technical decision. Once you have that upfront and you have a way of recording the protocol, what we are doing, in case somebody wants to know how come you end up doing this and that, we have an assess phase, which is exactly as I said. We analyze socio-technical scenario with this team in an iterative way, so you do it several times. You identify issues, you check if there is some evidence, and you keep on doing that until you reach a certain level of confidence that you figure it out most of the issues that are really risk and not only issues because you didn't find an evidence or not strong enough. And then you map it to the trustworthiness framework, and that's the mapping mechanism that I'll tell you. So this is an open vocabulary iteration. This becomes a closed vocabulary list of issues that can be placed to the last phase where you have you can present ethical tension, you can give possible trade-off and give recommendation to the stakeholders. So that's how, I mean, in a nutshell. In practice, much more complicated because then you have all kinds of nitty-gritty details you only learn when you are working with people in different contexts. Just to mention one thing, if you work in an organization, and this organization is used in an AI system that has been developed by somebody else, and it does not own the IP, then you have to figure it out upfront. What is the IP? How do you want to handle it? And since we don't want to get into auditing, because we are not requested by law, there will be a number of questions that you need to ask yourself if you want to look at a system and sign an NDA. This basically restricts strongly the way you can publish, so then it goes against transparency. At the same time, if you only look at the system as a black box, you can only make assumption of the model or the data. So it really depends on the system and the case, and it is important at least to manage it upfront. Now, the interesting thing is we are an initiative, so probably Jim mentioned that we started a few years ago, and we're still a pro bono initiative. It's not an association, it's not a company. We're just a network of motivated experts. And then we started to create this year a set of affiliated labs that are trustworthy AI labs, where they use our process for doing research or teaching. I'm actually quite happy to inform you that we have 8 at the moment, spread all over the world. Now, these are free, but we have more labs in Italy, Germany, in Malaysia. So, and the labs are growing. So, and this is a way where this kind of process can be used in other situations by organizations that are not for profit. On top of that, another thing that we want to do is to enable this process to be taught in university or selected teaching organization at various levels. And I'm quite happy to inform you that this is a mandatory course of a new master program that has been supported by the European Commission. It is an interdisciplinary master program on explaining artificial intelligence in healthcare that is offered by a consortium of 5 universities in Europe, and is 1 year. It will be open end of this month. So if somebody is interested, even in the attendees, to take part of this new master program, you need to monitor this website, because the application will start end of this month. But for us, it's very, very important because one of the compulsory module in the second semester is the inspection process. So for those of you, and you have a few things, so I'll send to Jim a copy of the slides so you can click on here. And to finish, we have a website, which is this one here, which has plenty of resources, all the paper published in the results, educational resources on teaching that I've been doing in Germany and in South Korea, plenty of resources on the topic of trustworthiness. And with that, I'm actually finished with my presentation. Thank you.
Fantastic progress, Roberto. I'm just in awe of the progress that's been made since that meeting several years ago before the pandemic at IBM Almaden. I want to just leave this slide up for a minute because I want people to know where to go to get additional information. z-inspection.org is the resource place. And if My second question, which you also answered, I think is on your previous slide. There was a course that's available,
Yeah,
and I believe the URL was
yeah. This
xaim.eu. That's what I
exactly.
was looking for,
Yeah.
xaim.eu. So we'll make sure those get associated with the material strongly. And I just have one question. I know we've run over a little bit, but this is just so amazing. I have to ask. You you were talking about a method um, where you're looking at vocabulary and trying to match vocabulary across disciplines. And I'm wondering if you could go back to that slide where you
So
mentioned that,
yeah, I can
um,
do that.
and then I can ask my question. Yeah, this fascinates me. We use a consensus process based on mappings, open to close vocabulary. And I'm fascinated by this for three reasons, and I'll just say them quickly, and it'd be great if you could comment. One is, I think one of the biggest challenges democracy faces today is that we have to be able to take conflict and turn it into consensus. And I think you're working on something that takes maybe some conflicting vocabulary and turns it into consensus. So curious about your thinking if if there's a way. Social media sometimes makes more money if there's more conflict. I'm wondering, and conflict isn't necessarily bad if it drives energy towards consensus and deeper understanding on both sides. So I know that's a vague question, but I'm wondering if your methodology might apply somehow in turning conflict into consensus. The second direction that I'm thinking about, I know we both share a computer science background, so I have to go a little, um, uh, is there a way that AI systems, which are very good at translating now between human languages, Chinese English, German English, very, very good transformer models for that. Do you know of any work? I guess this is a series of three questions now. Do you know of any work to apply AI to translate between disciplines? So economics and systems engineering, it seems like that's related to this open
Mhm,
vocabulary
mhm.
looking. And I hope you're taking notes because I've got one more thing in my
Yeah,
head before I
yeah.
stop. So there's the conflict to consensus. Is there an AI system that could help translate between these systems? And actually, I think that's enough. Let me stop there. I'll email you later with the third one, which is
Okay.
maybe even
Well,
more
thank you, Jim.
philosophical.
It's a really nice question because they go to the core of the problem. So the first question is, we have this consensus-based process, and you might have disagreements between various kind of experts. So what I was very surprised is to discover that if you have domain experts, for example, let's say you have a case where an AI system is supposed to be helping dermatologists to detect if you have a mole in your skin and if it's actually a potential tumor, the system might say, well, this is a dangerous spot, and then you might end up doing a tiny operation to remove it. So that was the beginning of this AI system in design. And then they have their own dermatologists on board. So they have somebody that knew the domain and he was actually happy about this design. And then we did this co-design. That was a case of co-design. And what we did, we said, okay, we need experts in that area. But rather than bringing only another dermatologist, as we did, we also brought in medical experts in a broader sense, like there's something called evidence-based medicine. They look at statistical things. And immediately, the first workshop that we had, when the engineer said, well, this system is supposed to have dermatologists for detecting skin cancer, the experts, that is professor of evidence-based medicine, said, I do not agree. Why? Because it was very concerned about overdiagnosis. So if the system has a ratio of too many false positive and a very low ratio of false negative, a dermatologist would be very happy because he's at least able to detect all dangerous cases, and he might do some unnecessary operation. But for somebody that is looking at the cost and risk of let's say, unnecessary operation, given some suggestion, that was really a no-go. So basically, we end up discovering that there was no way that we could find evidence to that because they were coming from different angles, and there was not a consensus. And it was actually listed as different viewpoints and map it to the trustworthiness in different viewpoints. And then basically whoever was designing this system have to make a trade-off and make a decision. But at least it was aware of this decision. That's a case of an internal consensus. That a consensus is not always possible, but it could be transparently mentioned. Another case, just to answer to your first question, is when the system is already deployed, so there's nothing that you can do about it, and you say, okay, now I want to understand what are the implications. Then you might have a legal scholar say, well, there is an issue. Then you might have a machine learning engineer who said there is an issue. You might have a medical doctor said there is an issue. And you may have even a applied ethicist that said there is an issue. They all talk the same issue, but in different ways. And now it comes the link to your second question. Until now, we've been doing most of our cases manually, meaning consensus-based meeting where experts do 1, 2, 3 meetings, reach out a minimal understanding of the terminology, because that's a mapping of terminology. And once they understood what is overlapping, what is different, then they do a mapping by deciding together what are the ethical principles and the requirements that seems to be more relevant. Then we discover that's very time consuming and is very much subjected to interpretation. It reminds me, since we are both in computer science and in database, it reminds me quite a bit of the old days of heterogeneous database where you had to merge different schemes, and then of course everybody
exactly
is different, and that was very difficult. So recently, in the last use case, we did an experiment, which is exactly what you were asking for. I cannot answer the question in general whether there are AI systems to bridge different disciplines, but I can tell you that we've been using natural language processing to cluster concepts that were in the narrative. So there were actually each group, if you have, for example, if you split the work in working groups, you have maybe medical doctors in one working group or legal scholar in another one, and then there is an attempt to bridge the two. Then we've been trying to use some natural language processing to cluster those automatically and present the commonality to the team in order to support the mapping. Now, the interesting thing that we have this in GitHub. So if somebody is interested to play around with that, we have open access. Yes, we have open access. And we did not completely do an evaluation to what kind of quantitative or qualitative benefit this has, because we only did it in one case. But for sure, this is an attempt to help the consensus-based process by identifying in the tree or in different other ways. Common in a graph could also be a possible way of doing it. But that's a very interesting area of research as well. But in reality, the most interesting thing for me, because I'm really looking at the applied results, is if it helps delivering good recommendation. Because frankly, you can lose yourself in research, but lose the meaning of the research, right? And for me, and probably like the people like you, very interesting is to really look at, is it helpful? Because otherwise, I have plenty of research on that. But these are very important questions. the interesting thing here, we are finishing up a big report, trying to write up all the lesson learned and giving practical tips. So as soon as this is, probably we put it in archive in the summer, and I'm happy to share it with all of you, because this is all what we learned in 3.5 years. So, and that would be like the reference of for us as well. So, but thank you for the question, very relevant.
So thank you, Roberto. It's clear we have to circle back in less than 3 years, but a fantastic talk. We ran a little over, but this is also excellent. I just want to congratulate you again on the ISSIP Award for Service Excellence Distinguished Recognition for the Innovation Z Inspection, a process to assess trustworthy AI in practice. Thanks so much, Roberto, and I'll stop the recording now.
Thank you. Thank you.